Good morning, Algebra 1. Today's lesson is going to be, chapter 3, section 2 of your book. And it's all about the wonderful world of ratios. Woohoo! Yay! I know. Okay, so let's go ahead and begin. And before we begin, I want you to make sure you have your pencil, paper, and close your books or your tablets. That way you are paying attention to what I'm saying. Remember to take notes. I know I'm not there, but I know you can do it by now. I've drilled you enough. Alrighty, so let's begin. So our very first question is, what exactly is a ratio? Alright, so this is an important definition to have. Alright, so a ratio is a comparison, okay, of two numbers, okay, a comparison of two numbers by a division, all right, so by division, not by a division, but by division, and is often expressed, okay, there we go, as a fraction, okay, I'm going to say it again, that way you can write it down, just in case you cannot read my gorgeous handwriting. All right, so a ratio is a comparison of two numbers by division and is often expressed as a fraction. All right, so a comparison of two numbers by division, often expressed as a fraction. Okay, so for instance, an example of a ratio would be the ratio 3. Oh boy, you have a little glitch. If you notice a little glitch, just kind of keep going, it'll happen. All right, example, as I said, would be 3 to 4. Okay, let's say for instance, the odds of you failing, the odds of you passing the bar exam would mean 3 to 4. Okay, bar exam would be the exam you take to become a lawyer. All right, so that means for every 4 students, 3 will pass the bar exam. Okay, let's pretend that's a ratio. All right, so I can write the ratio 3 to 4 as a fraction, or I can write it using our colons, 3 to 4, or I can actually just write it in word form, 3 to 4. Either way, I say all three of these written forms of ratios the exact same way, 3 to 4, 3 to 4, 3 to 4. Okay, so don't forget, when I see this fraction, this is also the fraction 3/4, but in this case I don't read it as 3/4. I say 3 to 4. Okay, so that's really simple. All right, so now, as I stated before, when we have a ratio, we're comparing two things, okay? So notice, for instance, like when I told you the example of the bar exam to become a lawyer, right? And I said 3 students for every 4 students, 3 will pass. So 3 pass of every 4 students. Okay, so in this case, we're trying to compare the passing rate of these students. Another example would be, for instance, let's say I had 4 questions, right? Let's say you're taking that test. And let's say that you know to finish on time, you need to answer 4 questions, right? Let's put bar back up there. All right, let's say you need to answer 4 questions every 3 minutes, okay? That is what we call, now this right here is a rate because we're dealing with time, okay? So if you're taking your bar exam, you know that only 3 out of every 4 students are going to pass. And then you know that if you're going to finish on time, because a lot of exams, just like our standardized tests, they are timed. So you say, okay, well, I know that if I'm going to finish on time, answer every single question, I need to answer 4 questions every 3 minutes. Okay? So those are some ways of writing ratios. Now, let's do a little example. Let's do a little work now. All right, so I'm going to give you some basic problems. And from these problems, we're going to create ratios. So I hope you have your pencil and paper ready. Let's say we have a school of 312 children. Lots of children. Okay, lots of kids. All right, so a school of 312 children has 168 girls, right, and 20 teachers. Okay, so what we need to do, according to our directions, and the directions, here are the directions, they want us to create a ratio of girls to students. First, we need to find out what's our number of girls. Well, according to this, we have 168 girls. So 168. How many students do we have? Well, we have 312 students total. All right, so I'm going to say 168. Use my little fraction bar. And now I'm going to put 312. So remember, this is girls, that's students. Now, this fraction is a large fraction, and it can actually be reduced. So if I were to reduce this, I can reduce it to the fraction 7/13. So that means out of every 13 students, 7 are girls. Okay? So 13 students, so out of every 13 students, 7 of those students will be girls. Now, the reason that we reduce our ratios is because it gives us a little bit more, it can help us understand the ratio even better. Saying that out of 312 students, there's 168 girls, well, it's a little bit hard to imagine these large numbers in our mind. But I can imagine 13 students, and I can imagine 7 of them being girls. This also tells me, you know what this also tells me? That it tells me that a little bit more than half of the students are girls. Okay, so just by looking at that, because I know that 7 plus 7, if we had exactly 14 students, that would be 7 to 7. That means half are girls. In this case, we have 6 and 7. So out of 13 students, 6 would be boys, 7 are girls. So more than half of our population of children are girls. Okay? So let's do another short example. All right, let's do another one. Let's use this exact same problem. All right, let's keep it simple. And this time we need to compare, so you don't have to rewrite a problem, just have to rewrite your directions. This time we are going to compare girls, which inadvertently I already did, girls to boys. All right, girls to boys. Now, here's what we need to do. So how many girls do we have? We have 168 girls. Okay? Now, here's the question. How many boys do we have? And how are we going to figure that out? Well, the problem tells me what to do. This problem tells me that I have 312 students, 168 are girls. So if I take my total number of students, 312, and I subtract it from my number of girls, that means I'll get my number of boys. Go ahead and work that out. Okay, what'd you get? You should have received or should have gotten the number 144. All right, so that means there are 144 boys. So now I have my ratio 144. All right, so now here we go. Now, of course, I need to take this ratio, which is very large in terms of its numbers, and I need to reduce it. Okay, so I'm going to reduce this, and it reduces to the fraction or to the ratio 7 to 6. That means for every 7 girls, there are 6 boys. For every 7 girls, there are 6 boys. Okay, now that's fairly simple, isn't it? That's not too bad. All right, let's try another one. Let's try another problem. Let's do this. Now we're going to switch to an entirely new situation. In this case, we're going to do what is called unit rate. Unit rate. All right, now a unit rate, and I want you to write this definition down before we work the problem. Unit rate. Okay, so what we were doing before is just simply a ratio. A unit rate, okay, first off, well, actually, let's not do unit rate. Let's just do the word rate first. Okay, so a rate is a ratio. So it's a ratio comparing numbers with different units. With different, oops, with different units. There we go. Different units. Okay. Now, of course, the easiest way that I remember different units, sometimes I can think of, for instance, if I had feet and yards, those are two different units. And so a rate in this case would be a ratio that's talking about feet to yards or something like that. Alrighty. Now, a unit rate, what we're talking about, unit rate is simply, okay, it is simply a rate in which the denominator, and I'm going to abbreviate denominator, is 1, okay? So remember, a rate is a ratio comparing numbers with different units. And then a unit rate is simply where it's a rate in which the denominator is 1. So let's see what does that actually look like? All right, so using the same problem, now I'm about to erase this. If you need this and you don't have it, pause it so you can write it. Okay, so what does that actually look like? What does that mean? All right, so that takes us to our next problem. Same thing, we have a school with 312 children. It has 168 girls, and we have 20 teachers. Okay, now this time, instead of comparing boys and girls or girls to children or girls to students, we are going to create a unit rate. There we go. A unit rate. Let's fix that. A few problems. There we go. We're going to create a unit rate of students. And I'm going to abbreviate students. So students per teachers. Okay. So we want to figure out how many students per teachers do we have. All right. So we know that our number of students we have is 312. So 312 children. So 312. Okay. That's how many students we have. And then we know that we have 20 teachers, which when we put that together gives us a ratio of 312 over 20. And when I reduce this now, when I reduce this fraction, it's going to reduce to 15 over 6. All right, so 15 over 6. Write that in there. Okay, so that means there are 15. All right, so that gives me the ratio 312 over 20. All right, so now notice, remember, a unit rate, if we were to think of our definition, a unit rate has to have a denominator of 1. Okay, a denominator of 1, which means I need to divide both of these numbers by whatever my denominator is. That way I can get the number 1. All right, so I need to have something with 1, and this guy, I don't know what this number is going to be. Okay, well, we do know. I do know, but we'll figure it out together. So that means I'm going to divide this guy by 20. That's how I get the 1. And that means I need to divide this man right here, this guy, by 20. So when I work this out, if I set it up 20, all right, 312. And I'm going to go ahead and annex some zeros because it's a possibility I'll get a decimal. More than likely I will. All right, so 20 goes into 312, or 20 goes into 31, I should say, once. Okay. We'll go ahead and subtract. There we go. Which will give us 1 to give us 11. All right. Bring down our 2 20 goes into 112 5 times. All right, so we know that that is 100. Okay, 112 minus 100 gives us 12. Has some little glitches. Just keep going. Okay, let me get my eraser. Fix that up. There we go. So 112 minus 100, that will give us 12. Bring down a 0. 20 goes into 120. Don't forget to put your decimal up top. That goes in there 6 times. All right, we know 6 times 2 gives us 12, so it actually goes in there perfectly. So that gives us 15.6. 15.6. That means for 15.6 students, right, you have one teacher. So remember, if I need to make a unit rate, go ahead and set up your ratio, in this case 312 over 20, and then take your denominator and divide your denominator into your numerator, which will give you your new numerator of your ratio. And of course your denominator will become 1. And that's how we do unit rate. Okay, now of course we know that you can't really have 15.6 students. That's a little on the more ridiculous side. So in this case we probably round it up. Well, actually, yeah, we could round it up to 16. For every 16 students, you would have one teacher. All right, students per teacher. And of course, in this case, it doesn't ask us to round, so we just leave it as a decimal. So 15.6 students per teacher. All right, let's try another problem. Let's do another one. Let's erase that. All right, but does this make sense so far? That's not too bad, correct? All right, let's go ahead and erase this. Let's get a whole new problem. All right, so we're going to be talking about another facet of ratios, and it uses the same techniques, except this is how we convert ratios, or not ratios, but convert units, okay? So as I said, this is our definition. I want you to go ahead and write this down. The purpose of this is, of course, as I said, this allows you to convert a rate to an equivalent rate, and you're going to see what that means. But here's the definition that you need. Unit multiplier. So a unit multiplier is a rate, okay? So it's the same thing we're used to working with. It's a rate with different expressions representing the same quantity in the numerator and the denominator. All right, lots of fancy words. All right, so say it again. It is a rate with different expressions representing the same quantity in the numerator and the denominator. Okay, so now let's see what that looks like. All right, let me go ahead and, like I said, if you're still writing this, you can go ahead and pause. You can pause your video and finish writing that down. Otherwise, keep working with me. All right, so in this problem, we are going to take 17,000 miles per hour, and we need to convert that from miles per hour to feet per second. All right, so let's 17,000 miles per hour. Let's pretend we're talking about a plane, something that moves very, very fast. And so instead of talking about how many miles per hour that you can go, we need to talk about how many feet per second that we can go. Alrighty, so notice we have miles per hour, and we need to change that into an equivalent feet per second. And right now we're just kind of analyzing it. We're not working it out just yet. We're just kind of analyzing so we can figure out what we need to do. So that means this mile is going to have to change to feet. Well, do we know any conversion facts between feet and miles? And yes, we do. We know that there are how many? 5,280 feet that equals 1 mile. So we know that. That means there's only really one step to go from miles to feet. That's perfect. Now, what about hours to seconds? Do you know how many seconds there are in an hour? Now, I don't know about you. Maybe you have it memorized, but I know I don't. But there is an easier conversion fact. I know how many minutes are in an hour, and then I know how many seconds are in that hour. So I'm actually going to have, or that minute, I should say, I'm actually going to have two conversion facts for this guy to go from hours to seconds. All right, so what were we saying? So how many minutes equal 1 hour? Well, that's easy. 60. There's 60 minutes in an hour. And then we can go from this minute, right? 1 minute can then link us to a second. All right, so how many seconds are in a minute? Well, that's 60. All right, so notice we needed a bridge basically to get from hours to seconds, and our bridge was minutes. Now you can have multiple bridges. In this case, it only took us one. You can have as many as you need to get from one unit to the other unit. Like I said, in this conversion, we only need one. So how many minutes are in an hour, and then how many seconds are in that minute. But notice for mile to feet, there is no bridge needed. We knew a fact just for that. All right, so now that we know the numbers that we're going to do, and I do like to do this fact, or this step I should say, because it goes ahead and it sets up, or gives me the numbers quickly at a glance of what I'm going to use to actually convert, okay? So it's just like a little bit of prep work. I mean, is it totally necessary? No. Is it useful? Yes, I think so. All right, so now that we know what we're doing, let's go ahead and begin to set this up. So we know that we're going to have 17,000 miles per hour. All right, so we're going to write our number, and you may not want to write too big. This can get a little long. So 17,000 miles, and we're going to set this up as a fraction, okay, per 1 hour. So we already said that we can go from feet straight to miles. So I need to get rid of my miles, okay, by putting miles on the bottom. This creates a cancellation, meaning that this unit is going to be canceled out. But now I need to change it to what? Instead of miles, I need to have feet. So I'm going to put feet on top. All right, so notice, I'm just going to start with the easier one because there's only one fact to convert from miles to feet. So I'm going to start with miles and feet. There's 2 facts for this guy, so we'll save him for last. All right, so now we said, what's our basic fact? 5,280. So I put 5,280 feet to miles. All right, so that takes care of our miles. Now our miles can cancel. Feet, perfect. We now have our feet, or our feet, not feet. Now we need to take this hour, and we need to take our hour, and we need to go to minutes, because hours to minutes. So since hour is in our denominator, and we want to get rid of him, we are then going to put an hour in our numerator to do that. All right. The unit that we want is a minute. All right. So I'm going to put minutes on bottom. All right. So how many hours or how many minutes were in an hour? Well, we have 1 next to our hour and 60 next to our minutes. Okay. Now we have that. So now our time, if you notice, we've gone from hours to minutes, and now I need to go from minutes to seconds. So since I want to get rid of our minutes, which is in our denominator, I'm going to put minutes in our numerator, seconds on the bottom. All right, and so here comes the question. We had a 1 next to our minute and 60 for our seconds. Okay, does that make sense so far? Good. Now, let's begin. Let's begin. So these 2 cancel out. All right, those hours cancel out. Those minutes cancel out. And all I'm left with is feet per second, which is exactly what they asked me for, feet per second. So I have my answer, feet, or I have it set up at least, feet per second. There we go. There we go. Second. Now, whoops, got a little glitch going. Let me see if I can fix that up. All right, so feet per second. There we go. Feet. This wants me to slow down for you, right? Pretend you can read that. All right. So now, then I'm just going to multiply straight across because these are basically fractions. And we know that when we're multiplying fractions, we multiply straight across. So I have 17,000 times 5,280. All right, so when I work that out, what do I get? All right, so when I work that out, I get the number. I actually get a very large number. I get the number 89,760,000 feet. Okay, and then of course when I multiply 60 times 60, which we know we could do the 6 times 6, which gives us 36. add 2 zeros. That's just quick math, right? We get 3,600. Alrighty, now we can't leave this as it is. Oh, but guess what? I can do a little cancellation before I actually do my work. Do you notice I have zeros on the end of this one and I have zeros on the end of our denominator? I can begin to cancel those zeros out. So I have 1 0 here. So that cancels out 1 0 there. And I have 1 0 here. That cancels out 1 0 here. Alright, so what I'm left with is, let's rewrite our number so we can see what happens. 7, 6, 0, 0. So now we've brought that down to 897,600. And we need to just divide that by 36. Alright, now, of course, when I work that out, I am going to get, so of course, when I divide that out, I'm actually going to get the answer, and I need to make a little room, so I'm going to erase this. Alright, let me get rid of that. When I divide that out, I get the answer, 24,933 feet per second. And that's our answer. Okay? That's not bad, right? All right, let's do another one because that was a lot of work. Now, well, it wasn't really a lot of work. I think it was just a lot of work because we went slow. But let's try another one. Okay, let's try another one. All right, so here's our next problem. This is actually a very simple problem. I think you'll find it more simple than what we did a second ago. We need to take 3 days and compare it or convert it to minutes. All right, now notice this is a straight conversion. This isn't quite a unit rate. This doesn't have any, it's not days per minute. Actually, we could do days per minute. Yes, well, we'll just keep it simple for right now. But it follows the exact same pattern, but it's just not a rate. Okay, so notice we start off with 3 days, and let's analyze it first so we don't make any mistakes. So we need to go from days to minutes. Okay, so our question would be, well, do you know how many minutes there are in a day? Well, I don't know about you, but I sure don't. So let's see if we can build some bridges towards minutes. So that means we can go from days. Now we're dealing with time. So what's the largest unit that you know that deals with days? Well, that would be hours. I can go from days to hours. I know that. How many hours are in a day? Okay, so you should have said 24 hours equals 1 day. And then I can go from that hour to minutes, right? Okay, so our hour is basically going to be our bridge. So how many minutes give us 1 hour? Well, that would be 60. And that'll bring us to our goal, which is minutes. All right, so now that we've analyzed it and we have our units set up and ready, or our conversion facts set up and ready, let's begin working it out. All right, so I'm going to start with 3 days. And because this is not, I'll slow it down till it catches up. Because this is not a rate, okay, it's not a rate. Oh, let me erase it. Our denominator is simply going to be 1. It's not going to have a specific unit underneath it, okay? So I have 3 days. All right, so I'll just put a 1, just kind of hold my place, right? So now I said that I'm going to go from days to hours, all right? So since days needs to be canceled out, and days are in our numerator, we're going to put days in our denominator and change it to an hour, okay? Okay, what was our conversion fact? Well, we said that 1 day gives us 24 hours. All right, now, then we said we need to go from hours to minutes. All right, so since hours is in our numerator, we're going to put hours in our denominator to get rid of it. We'll put minutes in our numerator, so that'll be the new unit. And our fact was that we had 60, there we go, 60 minutes per hour. Okay, pretend that's a 1. All right, so let me get this out the way. Okay. Now that we have everything set up, we can then multiply straight across. Remember, these are just fractions. They don't require any special way of solving them. Okay, so 1 times 1 times 1, of course, that'll just give us 1. And 3 times 24 times 60. Okay, so work that out. What do you get? Okay, so 3 times 24 times 60 gives us 4,320 minutes. Okay, so we can officially say that if you have, or if there are 3 days, all right, that in 3 days there are 4,320 minutes in those 3 days. Okay, so this is pretty simple work. Alrighty, using these techniques. If you learn these techniques, you'll be able to work any problem out, any type of ratio problem. All you have to do is dedicate yourself to memorizing these techniques. Although the problems may change, the numbers may be large, they may be small, but if you know the techniques, you can solve them using the same methods. Alright, so I hope you have a wonderful day, and see you soon.